Almost everyone at some point in their lives will think about reducing fat. So how do we go from this potential inches or centimeters thick of fat to this only a few millimeters thick? In today's video, we'll discuss what happens when your body burns fat. We'll look at how fat is taken from fat cells and potentially burned in different parts of the body. We'll also go over various myths and facts about how we can control where we pull out fat from, as well as whether there is a best sort of exercise for fat loss. It will be a squishy one. So let's do it. When most individuals discuss fat loss, they mean subcutaneous fat. Sub indicates below and cutaneous means skin. So it would be this fat right here, exactly beneath the skin. And as you can see, it may be up to an inch thick, covering up the rectus abdominis or six-pack muscles. Here's another example of fat that would cover the deltoid muscle. Thus, the concept is partially aesthetically pleasing. People want their muscles to shine through. Therefore, if the fat on top of the muscle can be reduced, those muscles will be more visible in all their majestic beauty. Even though thinner subcutaneous fats might allow you to see those muscles more clearly, we should not ignore visceral fat. Visceral refers to internal organs. So this is the fat that surrounds the organs. This is the abdominal cavity. Up here is this thoracic cavity, which contains the heart and lungs. Now in this particular body or dissection, it is a little more difficult to identify certain tissues and organs due to the visceral fat buildup, as shown by how thick and fatty the larger omentum is. You can observe thicker fatty appendages coming from the intestine, which accumulate visceral fat in between. What's more remarkable is the amount of visceral fat surrounding the heart. Yes, the heart is inside here, which is difficult to consider, especially given the appearance of a normal amount of visceral fat around the heart. The visceral fat inside here is also known as deep belly fat because as it accumulates, it can push on your abdominal wall and increase your waist circumference. The more we learn about visceral fat, the more we understand its links to certain health conditions such as metabolic syndrome, type 2 diabetes, high blood pressure, and other cardiovascular conditions, to name a few. But the good news is that we'll be able to remove this visceral fat in the same way that we would lose subcutaneous fat. And in the discussion about losing or burning fat, we'll take two different approaches. One is what we can simply do to stimulate fat loss, and two, what fascinates me the most is what happens inside the adipose tissue when we burn through it and thin it out. Like, where does everything go? So let's start with that, and then we'll go over some tactics for increasing fat loss. To demonstrate this, let us use an exercise as an example. Let's assume we are going to focus on the quadricep muscles, which are the large muscles on the anterior thigh. These quadricep muscles are exercising and require more energy, so we can draw from the fat stores to provide it. We might pluck from the fat on the abdomen. We could even pull from the fat around the shoulder here. But if we zoom in on this fatty tissue, we'll notice that it's primarily made up of these cells called adipocytes or adipose cells. And it's probably no surprise that these adipose cells store fat, which is stored as triglycerides. The three fatty acids chains are joined by a glycerol bond. And before we can truly extract the fat from the cells and distribute it throughout the body, we must first break down these triglycerides. And inside your adipose cells is an enzyme called hormone-sensitive lipase, which requires a little assistance to get activated. When we exercise, we release chemicals like cortisol and epinephrine, which you may be familiar with as adrenaline or non-adrenaline. And these three can aid in activating hormone-sensitive lipase and initiating the process known as lipolysis, which is just a fancy way of saying breaking down fat. And once we break down these lipids, those fatty acids can be released into the bloodstream. And as a side note, these fatty acids hate water. So because our bloodstream is mainly water, these fatty acids must be delivered alongside the protein. This protein is primarily composed of albumin. Albumin can be seen as a taxicab for fatty acids, and once inside, it can flow to the bloodstream and onto our working quadriceps. So now that we are in the bloodstream, some of these fatty acids may enter the femoral artery and travel to the working quadriceps via its branches. Once it's in the quadriceps, the muscle fibers may absorb it and channel it into the mitochondria to produce ATP. So it's kind of cool to visualize the entire process of getting to the quadriceps. But once we are in that mitochondria and making ATP, those of you who have taken biology before may recall that if we are doing this in the mitochondria, making ATP with fatty acids, we are going to do so aerobically. This means there is enough oxygen present. We only metabolize fats aerobically, whereas glucose or carbohydrates can be metabolized anaerobically without oxygen as well as aerobically with oxygen. To give you some numbers, if we metabolize glucose with oxygen and funnel some of the products of glucose metabolism into the mitochondria, we can get about 32 to 36 ATP from that glucose. Whereas the fatty acids, such as common fatty acids that is metabolized, palmitic acids, name is not essential, so I'm not sure why I mentioned it, but the common fatty acids can produce nearly 113 ATPs. So you might be wondering, what's the catch? Why don't we just consume fat for energy all the time? Why would we ever use carbohydrates? As we just learned, using fat for energy requires certain logistical considerations. We must remove it from storage, place it in the bloodstream, and transfer it to a muscle or another cell that may use those fatty acids, which could be in a different bodily location entirely. So there are multiple steps involved, and there is the distance concern. Yes, fats produce a lot of ATP per molecule, but it takes longer, and from an exercise standpoint, it takes about 10 to 20 minutes to ramp up your fat metabolism during exercise, and our muscles cannot store a lot of fat. So once again, we are relying heavily on fat storage if you want to use fat for energy in muscle tissue, whereas our muscles are excellent at storing glucose in the form of glycogen. Glucose produces less ATP per molecule, but it is readily available within the muscles and is much faster to metabolize and break down. So this brings us full circle to what happens within our body when we lose fat. As we continue to remove fatty acids from adipose cells, they will shrink in size. This will cause the entire tissue to thin out, adding to overall body fat loss and of course making those magnificent skeletal muscles more visible. Remember that the same principles that we covered can be used for visceral fat. We can extract fatty acids from visceral fat, reducing the overall amount within those body cavities. A common question about fat loss is, can you control where you pull the fat from based on exercise choices? For example, if you did a lot of crunches to work the rectus abdominis, could you encourage your body to preferentially pull from the fat above the belly to make this muscle more visible? Unfortunately, I have never seen any consistent evidence to support this. It's not like you could go do all these glute workouts and clench your butt cheeks all day long in between to try to convince your body, hey, just pull up fat from around my glutes so you can see that a little bit better. That's not going to happen. This is not to say that you cannot make a muscle more apparent by increasing its size. For example, if you did a lot of crunches and these muscle fibers hypertrophy or literally grew bigger, they might be a little more visible just because the muscles was larger underneath. But that wasn't because you told your body exactly where it could pull the fat from. The key is consistent overall fat loss, and the muscles will become visible as the body fat percentage decreases. Finally, we need to talk about what would be the ideal sort of exercise for fat loss. Is that something that genuinely exists? Is there a true fat burning zone that people should stay in if their primary goal is to lose fat? Well, it depends on what you understand by fat burning zone. Yes, there is a zone or level of exercise intensity where you burn a higher percentage or proportion of fat than carbohydrates. And you may initially assume, yes, let's exercise in that zone if the goal is fat loss. Well, proportions are one thing, but we also need to consider the total quantity or amount of fat burned. And let me give you an example to demonstrate this. Let's say we work in the fat burning zone and burn a higher proportion of fat than carbohydrates. We burned a total of 100 calories during this light exercise sessions, with 70% coming from fats and 30% coming from carbs. Because we are using nice round numbers, that means 70 calories from fats and 30 calories from carbohydrates, which you might think is where we want to be. If we completed another workout at a higher intensity on another day, we would have to transfer our energy expenditure from fats to carbohydrates. As the intensity increases, we simply don't have enough time to metabolize and utilize those fats. So we must shift back to carbohydrates. However, in that session, we burned a total of 500 calories, with 70% coming from carbohydrates and 30% from fat. So you can say, well, I merely burned less fat. No, because 30% of 500 equals to 150 calories from fat. In our earlier example, we only used 70 calories. Now don't quote me on those precise statistics from the preceding cases. I generally used nice round numbers to help you illustrate the point. But the last thing I want to mention about this idea of some perfect or optimum sort of exercise of fat reduction is, if we were to look at numerous different types of athletes. We are looking at runners and cyclists, basketball players, soccer players, tennis players, weightlifters, and even wide receivers in football, because yes, there are certain positions in football and other sports where some extra fat or weight may be beneficial. But for the most part, if you look at these different types of athletes, we will notice some differences in muscular development. Certain sports and training modalities would stimulate more, such as muscular endurance, adaptations, and the muscles would not become very huge, while other types of sports and training would stimulate the muscles to grow in size and everywhere in between. So, while we would notice differences in muscular growth, one thing these athletes would have in common is that they do not carry a lot of extra fat. So, what we can conclude from this is that there is no single best way to achieve this. There are numerous ways to be successful in burning and losing fat, and one of the most appealing aspects of exercise, in my opinion, is the variety of options available to us. We are more likely to participate in exercise consistently and thus achieve successful fat loss if we engage in exercise that we enjoy. So, if you enjoy long distance jogging, you may be able to reduce fat while doing so. If you enjoy high intensity exercise and intervals, you could lose weight and fat doing so. If you enjoy weight training or a combination of weight training and cardio, you can be successful, and participating in sports may help. The majority of the evidence suggests that it's more important to focus on overall caloric expenditure than on the amount of fat versus carbs burned. Yes, losing weight and fat can be easier said than done in certain scenarios. There are some variables we cannot control, like genetics, age, hormones, and so on, but I usually tell clients to focus on what we can control, which is how many calories we burn and how many calories we consume. So if we can be effective in burning more calories than we bring in or consume, we may be able to lose fat and weight, and after we have reached a point where we are satisfied, we may make adjustment to that inputs match outputs. So hopefully you learned something new and valuable about how the body burns fat. While we usually worry about how we can lose fat, I believe it may be beneficial for us to fatten up our brains with the videos shown on the screen. Thank you for watching over, everyone. If you feel the urge, please like and subscribe. Burn some calories by strongly leaving comments below, and we'll see you next time.